But again, this is highly non-trivial. You need to consider a suitable Chern-Simons interaction on an auxiliary 7-manifold with a boundary on the brane. And this is all sort of quite abstract and hard to carry out in practice. So we thought we could use the duality to type 2b string theory to make progress in this direction. So let me just review how actually the partition function on the M-theory side is then obtained. So carrying out the first couple of steps of Witten's procedure. So first we consider the normal classical partition function using this auxiliary action, which is given down here. I should mention I'm only going to talk about the classical partition function, which is just simply the sum over all fluxes. Of course, there's a prefactor then, which is given by the path integral over two-form fields, which includes also the moduli dependence, but I won't talk about that here. This result of this sum you can use Poisson resummation and factorize this into this sum of products of theta functions carried out by these people here. And well, these are the theta functions. They're labeled by these vectors alpha and beta. Alpha and beta are vectors of dimension 1/2 h3 of the divisor that the instanton is wrapped on, with entries 0 and 1/2. They label these choices of line bundle. And well, I won't talk much about this, but let me just point out some important features. So we see here there's a sum over integer valued vector of this same dimension here, k. There's a term here which is sort of quadratic in these k's, and we're considering here theta functions with a source q, and there's a term linear coupling this km and the source q. And the reason I'm pointing this out is because when we consider the partition function of an E3 instanton of O1 type, I'll come back to this in a second, we see actually similar structures here. We have sort of source, these G moduli, which include B2 and C2 moduli of type 2b string theory. And we see here again a sum over fluxes, and there's actually a linear sort of a coupling directly of the fluxes to these bulk fields, G, and also a quadratic term in the fluxes, so it's already quite similar in structure. Okay, let me mention that this result here is given for O1 E3 instantons. For these instantons, the flux is purely in H11 minus, so the even part, orientifold even part, is projected out. And the reason why we consider this is because the uplift is much clearer in this case, namely, especially if you then consider it specialize even further to a rigid and isolated divisor for the moment. Then actually the cohomology groups of the divisors are related in a very simple way, namely this third cohomology group of the divisor on the M-theory or F-theory side is simply twice H11 minus. So in other words, these vectors that are summed over in these two expressions here on the M-theory side and on the type 2b side are then vectors of the same dimension. Right? And this in particular means that we can directly match these partition functions with these straightforward identifications. And we recognize that we have to set these vectors alpha and beta to 0. So this, recall, was what labeled us these different line bundles on the intermediate Jacobian. So this actually allows us to identify which one of these partition functions is the correct one. Okay. So let me summarize for now and mention some of the very important open questions. So of course, this partition function of M5 instantons is difficult to identify directly in M or F theory. However, a way around, at least in models with a type 2b limit in F theory, is to determine this correct partition function via the duality with type 2b, where the partition function is unambiguous. And let me stress that this result, alpha and beta equals 0, seems quite robust. I mean, it doesn't depend on, it's not sort of a function of the geometry of the divisor. And in particular, you can sort of really see, even if the divisor is changed a little bit, you would still need to set it to 0, otherwise you would have sort of a term in the partition function where the flux is coupled to a constant, which doesn't appear on the type 2b side, roughly speaking. So basically the upshot is we expect that even though this explicit match, which relied on a match of the cohomology groups on the two sides, this mathematically we can only make it firm using these restrictions, so isolated rigid divisor, but we expect it to continue to hold. However, then of course, this, as I just mentioned, the cohomology groups are not related directly as before, and so there are additional 3 forms on the M-theory side, which would naively appear in the sum over all 3-form fluxes. So we would expect that there's some type of F-term mechanism, similarly to the F-term mechanism that restricts the flux on the 2b side to H11 and rules out H2, 0 or 0, 2 parts. And the corresponding mechanism should rule out the other forms in H3, so only the uplift of H11 minus should contribute. But the question is, what is this mechanism? And my final slide, well, just some speculative remarks. So there was some evidence given in this paper here that if there is a non-trivial intersection with D7 branes, then some of these negative parity 2 forms seem to uplift to non-harmonic forms on the F-theory side. And, well, this is really very speculative, but the question would really be what do these non-harmonic forms imply for the partition function? Does this mean we have to include non-harmonic fluxes? And if so, how do we know which ones that we should take into account? A different question would be, how should we uplift U1 instantons? Because these have fluxes with even orientifold parity, but even 2 forms don't uplift to 3 forms, they uplift to 2 forms, so they can't directly be identified as 3-form flux, which is again an open question. And finally, of course, how one could identify our result directly with witness construction.
Well, thank you very much.
Thanks.
Well, any questions?
Yeah.
Do you have charge modes in your partition functions, so you have intersection V7s?
Well, in the part that I showed, we did not really. We considered mostly isolated ones. Actually, in our paper, we also discussed quite a bit on what happens when there are intersections, and in particular, what happens when we include a G4 flux restricting to the instanton or and the 0 modes. But yeah, maybe I'm not quite sure what Timo will discuss, but I think he will have some words to say about that as well.
This match is very nice. I think one of the things that was confusing to me about with this paper, he has this thing that says pick it out based on this 7 manifold.
Yeah.
But it still sort of leaves open the question. I mean, the intermediate Jacobian is a complicated object, and in particular, as you vary the moduli in the M5 defining equation, this object is going to change. Do you have any idea how to really get your hands on it? My impression is that these things have only been explicitly constructed in very, very few cases, even by mathematicians.
No, to be honest, I must say I'm as lost as you are on that, and I think it's exactly as you say. It's extremely complicated. I don't know exactly how to even construct this 7 manifold in the most general case, or to try to identify these things. So, I mean, as I said before, Witten needs this 7 manifold ending on the M5 brane, you know, and so is that what you meant? Or?
Well, I sort of just meant that you're saying that this prefactor is a theta function on this intermediate Jacobian. Very few times in examples have people actually constructed these objects. I mean, if I actually give you an M5 local item, some non-Claudiat threefold, how do you get your hands on that object? I mean,
well, the intermediate Jacobian is basically just the H3 over H3Z, right?
Maybe I would pose it this way. It's going to depend on the moduli and the defining equation. So if you were to have a zero, if you were on the theta divisor, if you were at theta equals 0, how would you see that as a function of complex structure, for example?
Okay.
Seems like it's a point for.
Yeah,
for
maybe.
further
One does
discussion.
see that it vanishes, for example, to certain values of C3 or so.
Is that-
in the very form. So one does see the zero. Because there will be cancellations between phases. I mean, computing this and applying this to concrete geometry and then matching this, say, with duality, where you know that certain sections vanish or what, this is a different question. But that the structure that this is a section and that it has zeros because of phase is manifest from the structure which was shown.
Okay, I see. Yeah. So yeah, this is a non-trivial section over the space of, for example, C3 configurations, right? And so it will have zeros for certain configurations of the moduli.
All right, let's thank Max again. So.